the layer around the earth that keeps like oxygen in.
Okay, so here's my, my atmosphere has different layers, right? You come up here, when I breathe is my O2. Up here we have layers levels of O3. What is the O3 or the ozone block?
UV rays.
UVs, your ultraviolet rays. Ultraviolet rays, if they come in, what damage do they do? Skin cancer, cataracts. Anything else? UV rays damage DNA in just about any living organism. They do. They damage plants. They cause rubber things to decay quicker. Yeah, plastic. So this comes back, and if they're coming in, it helps to reflect some of them before they get through. Okay. What breaks down that ozone layer? Freon. Somebody else said something else? CFCs, like fluorocarbons. There is freon there. They used to be in the propellants in your spray stuff. Fire retardant. Fire retardant chemicals that we put on our clothing. The process of making styrofoam, those little packing things, uses CFCs. Aerosol. Now, are we doing something about it? Yes, they no longer put Freon in your air conditioner. There's something else. You know, I'd love somebody find out what that is. I don't know what that is either. Our aerosols no longer have that. I was reading my hairspray this morning going, oh, okay. Just looking for what is in there. I was very happy with the pump, you know, a little exercise. So, and the only way to stop this, what's the only way to stop this? Don't use babies. Right? I can't plant a tree and change it. Let's see. So, greenhouse effect is carbon dioxide and CH4. Who remembers what CH4 is? Methane. Okay, these are the greenhouse gases. How do they make it like a greenhouse? They trap the heat. This is global warming, right? We got this right. This is carbon dioxide. Where do I get carbon dioxide? Burning is just about anything. Anytime you burn, you have carbon dioxide. Has anyone not tried this? See me before you leave if you're listening. Okay. Oh, come on. I just had you said and you were working. Do this one. This is about where we stopped. Is that about where we stopped?
Yeah.
Okay. This is just showing because of greenhouse gases. Now remember, methane comes naturally cows, pigs, as they are digesting things. They actually give off methane. So this shows carbon dioxide in your parts per million in the atmosphere, starting back year 1 and coming forward. Someplace in here, about 1600. We start to have a rise in those greenhouse gases. What's going on? Industrial revolution. So what we have is the population is going up. We are more factories, more burning, that kind of thing.
I think you got to touch this. There you go. Tap it like this.
Okay, this is down in Brazil. This is 1975. You see the rainforest, you can see the rivers. Very little effects of civilization there. This is 26 years later. There's your river still. Look at all these. You can see streets, agriculture. All of this is going on. Just populations go up. We know that in a lot of the rainforests, we talked about how lots of rain, your nutrients cycle through so very quickly, your nutrient form, and things they do is they splash and burn. Burning helps to put it back in the cycle, back in the soil quicker. A lot of carbon dioxide off there. And then you'll have the plants. So who are your big users of carbon dioxide? Green plants. Photosynthesis is taking carbon, making glucose, which is a 6-carbon sugar. Okay, so big thing is fighting global warming. Green plants. Okay, per capita basis, which country consumes the most energy? United States, Russia, China, Brazil. Ready to go. Interesting. We have either the United States or China. Why is that? So many things are made in China now, right? We are still the leaders in the consumption of energy, but still the United States. We are used to a very, I don't want to say lush, but we're used to a lot of stuff that a lot of the rest of the world doesn't have. We actually have a pretty high standard of living. Any of you who have traveled, whether in the military or just for fun, you've seen what the rest of the world can live like. Okay, so CH4 methane, your sewage treatment centers that are dealing with waste give off a lot of CH4s, livestock, pigs, cows. As they break down the food that they eat, they give off methane. Anybody here ever watch Mad Max in the Power Dome? Yep. They take the methane gas from the pigs and they use it to keep the fish. I watch way too much TV and movies, and unfortunately you get to share that because I try to make a creative connection. How do you make it? I make connections. All right, so as the greenhouse gases, carbon dioxide, methane increase, more and more heat is trapped. This is where it gets your global warming. So ozone and greenhouse effect, two different things. Total amount of atmospheric carbon dioxide has increased 15 to 30% since 1896, so in a little over 1896, and a little over centuries, increased almost 20%. That's quite a bit. Consequences. Well, as temperature rises, the temperature changes. Now, guys, you would think that a temperature rise needs to be like 10 to 20 degrees. The difference overall, year-round, looking at climate, of 1 to 2 degrees makes a huge difference. Because remember, you are looking at an average. Sea levels are rising. Why are sea levels rising? Ice caps, glaciers are melting. There is not a glacier anywhere in our Earth today that is growing. They are all shrinking. Loss of forests and crops. Through the problems, remember, as you change your temperature, amount of water available, crops change. This is going to change plant distribution, and when you change what is growing there, you change the animals that can live there, so you get a change in animal distribution. You have increased evaporation of lakes and water, so you're losing water faster from your lakes than it is being replenished. Some people blame increased severity of storms on it. The problem with that is you always have bad storms. They're not unique. Yesterday, they had that big solar flare. Did anyone watch the news last night with pictures of the aurora borealis? Wasn't fantastic. Interfering with plane traffic. Yeah, what it does. Okay, this is showing So as you're putting the greenhouse effect, as the heat rises, you've got them melting. And we can do some things with this. This isn't huge, but I can add a graph to it. And I can put labels on it. Reset. It shows that it's a global warming. So as the gases and temperature rises, and then all the variable goes away. Not necessarily wonderful, but kind of fun. All right. So, how do we solve this? What do we do? Well, we plant more plants. The more green things that are out there growing, whether it's grass, whether it's a bush, whether it's a tree, you make sure you keep your forest instead of building housing development. Cut down on our burning of coal. Instead of letting our CH4, our methane, just go up into the atmosphere, collect it, and use it. Anything to do that, anything you do here. They have a wonderful windmill. Anybody drive up to or across Wyoming? You have these huge wind farms, and you just see just mile after mile of these big, huge wind things that go up. And as far as your environmental impact, there is so much less than. I had somebody one time, they had someone try to convince me it was wrong because it interfered with nesting birds. Why is that funny? Why is that funny?
But they do nest on the leaves.
It's not killing birds. The smart bird will fly around them. They're not so thick you can't get around them. That's true. We don't have any problems. You know what? They nest on schools. They nest on side of my house. They nest places. If it's dangerous for them, they will find another place to nest. It is not interfering with the trees.
They'll move.
Now look, that's right. It's not cutting down on the trees available for them to nest in, and it's fine.
It's really incredible to like drive by when a semi is carrying part of that windmill. They're huge. Like just one of those blades, they're huge. They are like an inheritance.
And we see them from way on the highway, way out there, and
You don't realize how big they are.
they're gigantic.
I have family out in the country.
My husband knows those.
Oh, really?
Yeah, they're
Is there much of a sound to that?
They have a humming.
We have a hum.
Yeah. They pay you a lot if you want to put them on your land.
Yeah, they do.
So they have a more, places out there.
You know, the side effects of them are so much less than so many things. You know, I'm going for it, because wind is always with us. I'm amazed at how many days when I drive in, that wind is going.
There's a city in Colorado that made one, where they basically all shipped in and did a big windmill, and it cut like a third or something like that of the electricity bill or something like that of the whole city. Just on like a big one. Yeah. Yeah, and they got a real big, a bigger one, and it just saved everyone money on it.
I know somebody who got an individual size, I don't know how big that would be, something for their own ranch, and they were using to generate. I thought, no. I cut my electricity bill. Iowa. If you are interested in your carbon footprint, remember carbon dioxide, www.nature.org, or you could go out and just say carbon footprint and Google it, and it would take you there. Chemical pollutants. We do have chemicals that will contaminate the water ecosystem. We use the chemicals, and then instead of dealing with them, we just kind of flush them down the toilet. industry, agriculture. Agriculture, we put so much on our plants, fertilizers, insecticides, wastewater treatment plants. I watch my finger, I'm used to a whiteboard. Landfills, our infrastructure is aging, so you've got storage tanks that are now leaking. All of those chemical pollutants. Anybody here ever have an oil leak or a leak from their engine in your car? Can you move and there's a little dot? Whether it is antifreeze or oil, when the rain comes, it goes into our storm drains, into our water system. It does pollute.
Well, that's like when they were talking about how, everybody was flushing all their medications down the toilet,
Oh, good, yeah, okay. Yeah.
and how it was affecting the water supply, and so they made all that, that one day where bring your pills to this drop off, and how many bottles of medication they had
Even
collected.
things like your batteries, your old batteries, if you will dispose, don't throw them in the garbage can, take them, you can contaminate, they break down. All right, mercury, biomagnification of mercury, remember we said mercury is one of those things that's stored in the fat that does harm. Mercury actually affects your, thank you, neurological. Mad Hatters, that's Minamata, Japan, where you had some industries that were putting mercury into the oceans, and the fish were contaminated with mercury, and then the people were eating the fish. Japan doesn't have enough fields to grow a lot of the things, we throw a cow out there, and we have lots of room for cows and such. They don't. Profit. I don't think so, and if I just use it better, what I wanted is to figure out why this won't work down here and it works up here. So what they had was over close to 200 infants born with what they called Minamata disease, because it was in this area around Minamata, Japan. They were grossly deformed, mentally retarded. These are the effects of the mercury in their diet. It does build up. If you live near the Great Lakes, there is a certain amount of mercury contamination, and they warn people to not eat fish from the Great Lakes every day. Cut down on the amount by that biomagnification. Okay, put your hands up. Burning fossil fuels and deforestation have resulted in an increase of the concentration of what in the atmosphere causes global climate change. Ready? Okay, we have a lot of ones and a lot of threes. CFCs are ozone. They have to do with ozone layer and skin cancer. We're talking about CO2. So that was good. Good job, guys. Yes. Somebody said I have a question?
No, you said trick question.
Yes. I have a question. We actually have a lot of people that confuse the ozone with greenhouse, so be careful. Ozone, ultraviolet, skin cancer. Oh, we need to get that off of there. Okay. Why? Because what we have done is we have violet flash, so a lot of the old is gone. And I swear every term that I'm going to get that done for you so you don't have to deal with that. Okay, now we are going to be dealing with, at this point, characteristics of the animal kingdom, the Animalia, that's your Latin root, or inning. You need to understand the characteristics that are used to separate animals into their phyla. And if you go back, we said the king plays chess on flat glass surfaces. So kingdom and Amalia, we've got 5 kingdoms, you need to know those. When I take the animal kingdom, I divide them into phyla. These are a pretty big separation. What is unique about that group of animals that we group them together? And there will be questions on, phyla and this stuff. Distinguish between the phyla that make up the kingdom and Amalia. You need to know the classes of the chordae. Do not panic. Your classes of your chordae, so we go animal kingdom, phylum Chordata, classes. These are the classes of animals that you started to study at a young age. Anybody know some classes of animals? Reptile, birds, fish, mammals, amphibians. Please, you know these, okay? We're going to give you college level names for them, but that's the classes of the animals, okay? When you go into, ask you what phylum does frogs belong to? Phylum Chordata, class Amphibia. Understand adaptations made for land and flight. If life starts in the ocean, what has to happen to these organisms that they can survive on land? What has to happen to an organism that they can survive or get flight? Okay? Okay, so animals. All of your animals are multicellular. They're made up of many cells. So once you hit kingdom Animalia, you are not dealing with protists, no paramecium. Okay? They are all heterotrophic. Heterotrophic. All of them eat another organism. Whether they're herbivores or carnivores, they eat somebody else. Why would we not have autotrophics there? They are not plants, they can't do photosynthesis. There isn't an animal around that does photosynthesis, okay? That's plants, that's a whole different kingdom. They are eukaryotic. Have we used that enough that makes sense to you? Anybody here remember the difference between a prokaryotic cell and the eukaryotic? Yes. Okay. Closed is not cell membrane, it is. Okay. Prokaryotic. Simple cells lack a membrane-bound nucleus. Okay. Prokaryotic tend to be your bacteria. They don't have a lot of organelles.
Oh, that'd be your bacteria.
Yeah. So your bacteria. Eukaryotic, once you get to eukaryotic, there's no bacteria. Eukaryotic, they have a more advanced cell. So they take that DNA that is so important, they put it in a membrane and make the nucleus.
So prokaryotic doesn't have a nucleus period? Or does
It
it
has a
have a bound?
nucleoid region.
Uh-huh.
See now, in the eukaryotic, it's so important, I give it a membrane. I lock it away safe. Okay? I put it in a safe place. I deposit it. Prokaryotic, I just say, okay, keep it over here. In this region. It's not separated.
Okay.
Just sit there. Okay? Eukaryotics have a lot of organelles. Mitochondria, endoplasmic reticulum, lysosomes. It has a lot of little things that have jobs. Okay? Animals have unique tissues. This is muscle tissue. This is skin tissue. This is, unique tissues with unique jobs. They reproduce sexually. What does sexual reproduction take? Okay, sperm and reproduction. Male and female. Takes two to tango, right? So, sexual reproduction, it takes two, male and female. And what would asexual reproduction? Cloning. right?
Or seahorses.
Now, I'm sorry, what?
Or seahorses.
Do they clone?
No.
The male carries the.
The male, but you have, for fertilization, you have a male, you have a female, you have egg, you have sperm. The only difference is the male carries them in his pouch.
What about a worm?
Worms are, we're gonna get to those.
Okay.
They are hermaphroditic, but you do have male and female. Hermaphroditic, anybody know what a hermaphroditic? They can change their sex? No, they have both.
Oh.
So worms tend to have both ovaries and testes. There was a hand?
Do seahorses fall into that category too?
No.
They're-
They're just unique because the male gets the babies in the pouch.
Oh, so, okay.
Yeah, no. No cell walls. Now, your bacteria have cell walls. In your animal kingdom, you have cell membranes. So when you are fighting something, you fight the differences. So I can come up with things that attack the cell walls of bacteria, and they will leave my cells alone. Okay. How do we start out classifying? Well, first of all, body symmetry. This has to do with the shape and form of the individual organism. Symmetry, where can I divide it equally? If you've ever cut out hearts for Valentine's Day, you know that works because they're symmetrical, right? Mirror images. Number of germ layers. Now, guys, this does not have to do with bacteria, and we will show you what we mean by a germ layer. The presence of a body cavity. Don't worry about it. We're going to talk about it. Origin of the mouth, the oral cavity. What develops first? Now, some of these, germ layers, origin of the mouth, we're looking at the embryonic stages. What develops and how, as your fetus or your embryo is developing, what starts first? Your oral cavity? Anybody know another big opening that we all have? Anus. So what starts first, the mouth and the anus? Presence of cephalization. Symphysis, does it have a head? Body segments. Head, torso, legs, and body segments. Insects, there's a lot of that, right? Head, thorax, abdomen. And then again, sexual reproduction. We need a partner. And we're going to go over all of these, so don't worry about it. You know, we're going to fill these in. So here we have a G-star, and this week in lab you should at least look at one and talk about it quickly. The adults, we have male and female, we have the egg and sperm. What do we call the joining of egg and sperm?
No.
What? Yeah,
Was it fertilization?
fertilization, that's it. A lot of people say conception. The word I'm looking for is fertilization. You're right, fertilization. That first fertilized cell is your zygote, and then that cell divides. You know, you have the vascula. Here you are, it's dividing more and more. At this point, we're starting to have the germ layers. You have your ectoderm, which is your outer layer. You have your endoderm, which is your inner layer. And in here we have a mesoderm, meso middle. Okay.
Where are they called germ layers?
There's another meaning of germ other than bud. That's not very, doesn't take time right now.
Okay.
Okay. Here we have the larval form of it. Doesn't look at all like the adults. It's going to go through metamorphosis. Just like frogs and tadpoles looks nothing like the adult frog. It actually goes through a change. Baby humans look like adult humans, just smaller. So we go not metamorphosis. Okay. Body symmetry. This is the dividing of the animal body so that there are similar or mirror body parts. Again, if you've ever cut out certain things, you know all about that. Shamrock parts you are cutting out. normal temperature.